This is a test review for geometric sequence and binomial expansions. Question 1. Find the summation of a geometric sequence. First of all, we know this is a geometric sequence. So the formula is exponential form. And from this form, we know that base equals -1/3, which means ratio equals -1/3. According to that formula, we know for this sigma notation, we got S15 minus S7 minus 1 is 6. Therefore, we need to figure out A sub 1 equals 8 times -1/3 to the first power. Therefore, we got -8/3. Then we plug into that formula now. We got S15 means A sub 1 times 1 minus R to the 15th power over 1 minus R. Then subtract A sub 1 times 1 minus R to the 6th power over 1 minus R. Since we have the same denominator, I just plug in 1 minus -1/3. A sub 1, that's -8/3 times 1 minus -1/3 to the 15th power. Then minus -8/3 times 1 minus -1/3 to the 6th power. So we put all this into calculator. We got -0.00274. That's the answer for A. Let's go to B. We want to get the summation n is from 4 to infinity of a geometric sequence. For this one, we know the formula, it will be A4, 1 minus R. This is an exponential function. Base equals -1/6. That will be a common ratio. And fourth term, A sub 4 equals 9 times -1/6 to the 4th power. We put into calculator, we got 1/144. Then we plug into this formula. We got 1/144. Then divide by 1 minus -1/6. We put into calculator, we will get equals 1/168. If we turn it into decimal, it will be 0.00595. Question 2. Consider an infinite geometric sequence. This one. Keywords, here's the geometric sequence. Find the value of R, find the 10th term, find the sum to infinity of this sequence. Find the value of R. common ratio are always any term divided by previous term. So I got -1,800 divided by 3,000. So reduce, you will get -3/5. That's the ratio. For B, find the 10th term. So we got to use that formula. A sub n equals A sub 1 times common ratio n minus 1's power. So A sub 10 equals A sub 1, that's 3,000 times -3/5. You got to do 9's power. Then equals -30.233. C is find the sum to infinity of this sequence. We know that sum to infinity equals A sub 1 over 1 minus r. Therefore, we plug in sum to infinity equals A sub 1, that's 3,000 over 1 minus -3/5. Put into calculator, we will get 1875. That's the answer for C. For number 3, consider an infinite geometric sequence. This one. Find the value of R. So for A, definitely R equals any term over previous term. Therefore, we got 5/25 equals 1/5. For B, find the 10th term. We know that formula is A sub n equals A sub 1. R is n minus 1's power. Therefore, A sub 10 equals A sub 1 is 25 times 1/5 to the 9th power. Put into calculator, we will get 0.0000128. That's the solution to B. For C, we need to figure out nth term of this geometric sequence. According to the formula, A sub n equals A sub 1 r to the n minus 1's power. We just plug in A sub 1 equals 25 times 1/5 to n minus the first power. This will be the general form. For D, we need to figure out the sum to infinity of this sequence. So sum to infinity equals A sub 1 over 1 minus r. Therefore, I plug in A sub 1, that's 25 over 1 minus 1/5. So answer will be 25/4. For number 4, in a geometric sequence, U sub 1 equals this, then U sub 4 equals that. Find the value of R. Find the smallest value of n for which S sub n greater than 40. So we know that U sub n over U sub m equals R n minus m. Therefore, for a part, n equals 4 and m equals 1 now. So we plug in u sub n, that means u sub 4 over u sub 1 equals r. It's 4 minus 1. So we got r to the third power equals u sub 4, that's 1 over 3. U sub 1 means 1 over 81. Then this is a complex fraction jump. This one drop down. You will get 81 over 3, that's 27. So we got 27 equals r to the third power. Do the cubic root, both sides. So we got r equals 3. If we want to get s sub n greater than 40, you have to figure out that s sub n equals, according to the formula, a sub 1 minus r to the nth power over 1 minus r. So we plug in a sub 1, that's 1 over 81. Then 1 minus 3 to the nth power. Then here is 1 minus 3. So we got equals 81. You can drop down. 81 times negative 2. That will be negative 162. Then 1 minus 3 to the nth power. We can move negative sign to the top. We got 3 to the nth power minus 1 over 162. You need to set up for this one. It should be greater than 40. Then we solve these inequalities now. So we got 3n minus 1, 162 greater than 40. Multiply by 162 both sides. Because this is an exponential equation, you need to isolate exponential form. Therefore, we get rid of the denominator by multiplying 162 both sides. Then we got 3n minus 1 greater than. We got 6480 on the right side. Then you add 1 both sides. So we got 3 to the nth power greater than 6481. Then we do log base 3 both sides. So cancel this one, we got the n greater than 7.99, which means n equals 8. For number 5, expand this sigma notation as the sum of 4 terms. Summation r is from 4 to 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth power, means 4 to the 7 of 2 to the rth 2 to the 4th power plus 2 to the 5th power plus 2 to the 6th power plus 2 to the 7th power. For B, find the value of sigma notation. R is from 4 to 30, 2 to the r's power. First of all, we know this is a geometric sequence because this is an exponential function. Therefore, your ratio equals 2. And we know s sub 30 minus s sub 3. Therefore, I plug in a sub 1 definitely means 2 to the 1st power equals 2. Therefore, using that formula, s sub n equals a sub 1 times 1 minus r to the nth power over 1 minus r. Therefore, I will get 2 times 1 minus 2 to the 30th power over 1 minus 2. Then subtract 2 times 1 minus 2 to the 3rd power, then 1 minus 2. We put all these one into calculator. You will get the answer will be really big number. For C, explain why sum to infinity cannot be valued. Because for this sigma notation, the common ratio that's 2 is greater than 1. That's the reason it cannot be valued. For number 6, consider an infinity geometric sequence is this one. Find the 10th term. From given information, we know that a sub 1 equals 3, and a ratio will be 3 times 0.9 over 3 equals 0.9. Therefore, for 10th term, it will be a sub 10 equals a sub 1 times the ratio 10 minus 1's power. Therefore, we got 3 times 0.9 to the 9th power. Then for B, find the sum to infinity of this sequence. That's sum to infinity equals a sub 1 over 1 minus r. Therefore, I plug in 3 over 1 minus 0.9 equals 3 over 0.1, that's 30. For number 7, consider an infinite geometric sequence is this one. Then find the common ratio r. Given your answer as a fraction in his simplest form. So we got the r equals any term over previous term. Therefore, I got 270 over 4 405. Simplify, you got 2 over 3 will be the simplest fraction form. Find the 15th term of this series, which means we need to figure out s sub 15. So we plug into that formula, we got a sub 1 minus r to the 15th power over 1 minus r. Therefore, we plug in. We got a sub 1, that's 405, times 1 minus 2 over 3 to the 15th power. Then over 1 minus 2 over 3. We put into calculator, you will get 1212.23. That's the solution to B. C, find the sum to infinity of this sequence. Therefore, we need the sum to infinity equals a sub 1 over 1 minus r. Therefore, we plug in, got 405 over 1 minus 2 over 3. So we got 1215. For number 8, the first 4 terms sequence are this one. Use all 4 terms to show that this is a geometric sequence. The definition for geometric sequence will be any term over previous term equals a constant. Therefore, you need to show that a sub 2 over a sub 1 equals 54 over 18 equals 3. And a sub 3 over a sub 2 equals 162 over 54 equals 3. And a sub 4 over a sub 3 equals 486 over previous is 162 equals 3. So it is a geometric sequence. Now we finish A part. B, find an expression of nth term of this geometric sequence. We already got a sub 1 equals 18, and ratio equals 3. Therefore, a sub n equals a sub 1 times r to the n minus first power. Therefore, we plug in a sub 1 is 18 times r, that means 3 to n minus first power. That's a sub n now. So we finish B. For C, find the value of n if n terms of this geometric sequence is this one. Therefore, we got a sub n equals 1062882. Now we plug in the general form. That's 18 times 3 to the n minus the first power equals 1062882. Then solve this exponential equation. We divide by 18 both sides. In this way, we can isolate that exponential form. Therefore, we got 3 to the n minus first power equals 59049. Then we do log base 3 both sides. On the left side, we got n minus 1. On the right side, we put this into calculator. We got 10 for the right side. Then n equals 10 plus 1 means 11. That's for C. For number 9, consider the geometric sequence is this one. And find the value of R. Then find the 15th term. For this question, since it's so similar to the question above, I just give the answer. R equals -2 for A, and B A sub 15 will be this value. Number 10, if this 3 is a geometric sequence, find the value of x. For geometric sequence, I have A, B, C. Therefore, we got the B squared equals A times C. So we got A, B, C, and B squared equals A times C. B squared, we plug in x plus 1 squared equals x minus 3 times 2x plus 8. Therefore, we expand x plus 1 squared, that's x squared plus 2x plus 1. Because we have a plus b squared equals a squared plus 2ab plus b squared. On the right side, you need to do the FOIL. So we got 2x squared plus 8x minus 6x minus 24. Since this is a geometric pattern equation, so I move everything to the right side because I want to get coefficient for x squared is a positive. We got negative x squared here, negative 2x, then minus 1. So we got x squared minus 25. This will be power pattern, so isolating x squared equals 25. We do square root of both sides. Don't forget plus or minus. So we get the x equals plus or minus 5. This is the answer for A part. How to get the common ratio R? I will plug in x1 equals 5 to this geometric sequence, and also x2 equals -5 into this geometric sequence. We will get, when we plug x1 equals 5, we got this geometric sequence. Then R will be 6/2 equals 3. When we plug in -5 to this geometric sequence, this will be the geometric sequence we got. So R equals -4/-8 equals 1/2. In other words, we have two solutions for R.